Hi everyone, welcome back. Hope you are doing good. So in this part of the solutions concept, we will be discussing about the different concentration terms used in the topic of solutions. So there are different concentration terms like molarity, normality, molality. You will also see the importance of these basic terms of concentrations in the coming topic of solutions. So let's start our topic. Concentration of solutions. So when you know that you have a solute in a given solvent, so that means you will be dealing with another important term, concentration. So concentration of a given, again I am writing this is important. If you understand this basic thing that solute plus solvent gives rise to solution, most of the concentration terms are easily understand. The first term, the concentration term, what is concentration of a solution? So the solute, the amount of solute in a given, the amount of solute in given volume of solvent is called the solution. So the more the amount of solute in given volume, in a given volume of solvent, the more is the concentration of the solution. Right. So for example, if you consider 1 tablespoon of salt in water, this solution will be having a particular concentration of amount, for example x grams of solute in a y grams of solvent. Right. Next, if you increase 1 tablespoon of salt to 3 tablespoon in a given amount of water, same amount of water, the concentration of the concentration C of the resultant solution will be increased. Why? Because here the solution, the concentration of solution is defined as amount of solute, which is x grams in a given amount of solvent, right? Or given amount of, even you consider total amount of solution also, it will be same, right? If you consider the given amount of solution also, it will be same, right? So here initially it is x grams, which is 1 tablespoon. Here it will be now 3 tablespoons. So x is increasing, y the volume of the solution will be remaining same, right? So concentration is nothing but amount of solute in a given volume of solvent, or you can generally, the volume of solvent will be nearly equal to volume of solvent will be nearly equal to volume of solution. So you can express this in two ways. One is amount of solute in V volume of solvent, or if this C volume is most cases is equal to volume of solution, you can also write this as the same x by V. Here it is the volume of solvent, here it is the volume of solution. So higher is the amount of the solute particles in the given solvent or in the given solution, higher will be the concentration. So this is one beautiful example to say that if the amount of solute is increasing, the amount of concentration is also increasing. Next basic term. So there are different percentages with which you can express the concentrations terms, right? Now the same logic again, solute plus solvent is solution, isn't it? Why I am stressing on this is because if you understand this, the most concentration terms are easily understood. So this solute will be having certain mass, will be having certain volume, will be having certain density. This solvent will be having certain mass. So I will be writing M1 V1 rho 1. Here I will be writing M2 V2 rho 2. The resultant solution will be also having certain mass, certain volume and certain density. So now what is weight percentage? So weight percentage is nothing but mass of this solute present in 100 grams of a given solution. So it is defined as mass by mass of solute and mass of solution into 100, right? So since we are discussing for 100 grams of the solution. Now what is weight volume percentage? Weight volume percentage is nothing but mass of this solute by volume of the given solution into 100. So this is weight volume percentage. Next, volume percentage. Volume of this solute V1, which is present in again 100 ml of the given solution, sorry, not rho, this V3. So volume of the solute present in given volume of the solution into 100 gives me the volume percentage. So generally this volume percentage will be used when you have the solute in a liquid state, right? Otherwise you generally use weight volume percentage only. So these are the different concentrations, or these are the different percentage concentration which you will be using to express the concentration of the given solution. Next, basic terms. Molarity. What is molarity? Molarity is nothing but it is one of the important way to measure the concentration of solution. Just like you are using percentage concentration, molarity is also one of the important way to measure the concentration of a given solution. What is molarity? Molarity is nothing but mass of the solute, or sorry, moles of the solute present in volume of a solution in liters. So when I am speaking that, when I spoke that you have a given solute of a mass m, so that given mass can be converted into moles when you divide with gram molecular weight. So molarity is nothing but moles of the solute. So what is moles of the solute? Mass of the given solute by gram molecular weight of the given solute. So if you do so, you will get molarity. So molarity of the solute is nothing but number of moles or number of moles of the given solute present in volume of a solution in liters. So remember, volume of solution should be taken in liters. This is one important thing. So 1 molar solution contains, obviously when you have 1 molar solution is nothing but molarity is 1. So when this is 1, number of moles of the solute will be 1 and volume of the solution is also 1. So 1 molar solution contains 1 mole solute in every 1 liter of solution. So units of molarity are mole per liter. So it is obvious thing because it is mole, this is mole and this is liter. So units of molarity are mole per liter, and the symbol is M, capital M. The symbol is capital M. So we have already discussed this, that molarity is moles of solute, volume of solution liter. So if we have molarity, and if you know the volume, if you know the molarity, and if you know the volume, you can if you know the number of moles and if you know the volume of the given solution, that is, if you know the number of moles of solute, if you know the volume of solution, you can calculate molarity accordingly. And if you know the molarity and if you know the volume, you can calculate number of moles. And if you know molarity, if you know the number of moles of solute, you can calculate volume accordingly. And if you know the mole of solute, and you can calculate the number of grams, the grams of a given solute, right? How? Because number of moles is nothing but weight of the given solution in weight of the given solute in grams by gram molecular weight. So gram molecular weight is the standard value, and if you know the number of moles, you can calculate the weight of the given solute. Next important concentration term is mole fraction. So if you see here, this is a solution. In this solution, there are A particles. So since A particles are larger in number, obviously A particles will be solvent, and B particles will be solute, right, since B particles are very less in number. So what is mole fraction? Mole fraction is nothing but mole fraction of a given component, here A, is nothing but moles of A, right, moles of A. So if you know that this is a solvent, that means that solvent will be having certain weight. So if you know the weight and if you know the composition of the given solvent or the formula of the given solvent, you can calculate the gram molecular weight. So if you know the weight, if you know the gram molecular weight or gram atomic weight, you can calculate. So this can be gram atomic weight also. You can calculate the number of moles. So number of moles is of A is known. Similarly, if you calculate the number of moles of B, right, so you can calculate the sum of moles of all components. So here it will be Na, it will be Na plus Nb. So this ratio of Na to the ratio of Na plus Nb is called mole fraction of a given component A. Next, mole fraction of B. So similarly the same concept here. Now B is a solute, right? So if you know B is a solute, that solute will be having certain weight, that solute will be having certain gram atomic weight, right, or gram molecular weight. So if you know the weight and if you know gram atomic weight or gram molecular weight, you can calculate the number of moles accordingly. So it will be mole fraction of B will be, remember this will be mole fraction of A, this will be mole fraction of B. So the moles of B, number of moles of B, and to the total sum of moles of all components Na plus Nb. So mole fraction of B will be moles of B by sum of moles of all components Na plus Nb. So since A and B make up the entire mixture, so since solute and solvent make the entire mixture, the mole fraction, the sum of mole fractions, the sum of mole fractions of A plus sum of mole fraction of B will be always equal to 1. So this is the important relationship which you will be getting, right? Since how you will get, since XA is Na by Na plus Nb and XB will be Nb by Na plus Nb. If you add both of them, what you will get? If you add both of them, we will get Na by Na plus Nb plus Nb by Na plus Nb. So numerator and the numerator, this can, since denominator is same, so this will be Na plus Nb on the numerator, so this and this gets cancelled, so it will be 1. So that's why the sum of the mole fraction of A and sum of mole fraction of B will be always 1. So this is one of the important concentration term which is used in solutions topic.